Hey guys, so this will be the longer version of the TIE Fighter build, where I try to include everything I had to leave out in the short video. Also, if you don't have any idea why you're here, I would highly recommend you to watch the short TIE Fighter video first, and then come back. I will link that somewhere up here. We're starting off with the design. And I did start off with this really awesome model by Tom3 Inc., which I found online, and used this as a really as a baseline. And as you can see, I did cut out the wings in the Microsoft 3D Builder, imported that thing into Fusion, and there's a button which says convert to BD wrap, which you can find somewhere with a right click to the model's properties. There were still a few chunks that I couldn't cut in 3D Builder, so from this point on I could do sketches on all the planes, and I could just get rid of all the excess material. And from then on I could start to add all the features I need for the later build. Here I do start to hollow out the model to make room for all the electronics and background lighting. Also, you see that big hole going through all of the model, which will be later inserted a steel rod to tie everything together. From then on, I got back to the original model, deleted the main body to just have the wings left, and in this case just one wing, which I drew the basic shape, added all the features I needed, and made all the cutouts, and just did a basic layout for the steel tubings frame, which I welded later on. This cutout you see me sketching up here will become the hinge point for the wall mount. And from here on I'm focusing on the dome. So this model featured a kind of oval shaped dome, and in the first clip you saw me resketching that oval dome. I used that shape to basically redesign everything, put all my features in. Also you can see these two notches which will hold the acrylic backlit frame later on, and also acrylic glass in the front. So this is basically the overview of the whole TIE Fighter assembly. Next up, we're gonna talk about 3D printing. All the small accessories and the whole main body have been 3D printed, and this was what got me unable to build such a large volume model with so much detail in it in such a rather short time. This clip is of the SLA printing and also hardening in the UV light chamber. You might recognize this time lapse of the dome and the main body. This was over the course of 2 days. If you're interested in oddly satisfying sound effects, well, hold on to your hats. So this is the pile of support structures I had to remove. The first side took approximately 1 hour, the second side about 13 seconds. So I guess I have to dial in my support settings a bit. We'll see on the next part. But have a look at this. So there's a lot of finishing work to do. If you wonder, this is just shy of 2 kilograms of PLA. This was the biggest spool I could get. And printing time was about 53 hours on this part. In the design, I sketched up 3 holes, which you see me reaming in here. And there will be 3 dowel pins locating the 2 pieces to each other. Because I didn't want to filler and sand the whole main body to an extent where I was comfortable with the result, I decided to use 2K epoxy to cover the whole surface. I guess you can just go with any epoxy you want. I got no affiliation to this stuff, but I was quite happy with it. Also, you see me using some kind of thickening agent which helps to make the epoxy more viscous. I choose to apply it on the lathe because on one hand that was a relative easy way to hold on to the part, and on the other hand I could use the spinning motion to not have the epoxy drip to basically one place, and that worked really well for me. I did leave it running for about 6 hours, and I think it was around 30 RPM. And as you can see, you really got a very shiny finish on it, and all the layer lines from 3D printing basically disappeared. Next up was the central steel rod, which I cut to length, got rid of all the rust with some emery cloth. faced and chamfered both ends. And used the horizontal mill to bring in the two M8 threads you saw in the CAD at the beginning, which I brought into both ends. So I was starting with the dome thing in front of the TIE Fighter, the cockpit you might say. And I went ahead and spray filleted these. This one is also being ground with the emery cloth. This one has to be done. I already did put in some small magnets which will attach to the TIE Fighter's front. So this and a bit of acrylic glass and we're good to go. So I've cut the raw shape of one of the windows I want to set in here. And if you're working with the thermoplastic material, there's always a great way to get three-dimensional parts, which is to heat them up for a short moment till they reach their glass temperature, and you can work with them. Alright, let's see if I can do this with the camera in front of me. So I've placed the part on an aluminium block I put in the oven, so the heat gets spread very evenly. Yeah, this is perfect. So take it out, you got a few seconds to work with this piece. Try to push it down on all edges. And then I used to give it a bit of cooling. So now I can glue it in place without any tension on it. So, rinse and repeat. Next up, we're having a peek at the electronics. You saw me fiddling around with the LED strips, which are fully controllable WS2812B LED strips, but we'll have a closer look at them later on when we get to the Arduino programming. So nothing fancy on the electronic side, it's just an Arduino, the step-down controller, which is 5-volt powered by a cheap power bank. So each of these systems do have two LEDs wired in series. So the step-down controller I can provide around 3.5 volts, which enables me to run the system without any resistors. The Arduino is basically just there to run the LED strips. In this clip you see the making of the LED strip that enlights the whole dome. In terms of Arduino programming, I really did try to live an easy life and just used two existing libraries, which is the Fast LED and the Adafruit NeoPixel library. I did go that route because I had to independently control two LED circuits. For the running lights, I did find a very excellent fitting void in, I guess, the Fast LED library, which I just fine-tuned parameter-wise to fit the strip's length and arrangement. Speaking of arrangement, the whole TIE Fighter consists of basically 4 LED strips wired in parallel. This is basically one of them. The cables attach at the far outer end. Then everything is kind of mirrored down the one wing, and then the whole assembly is mirrored to the other wing. So I get away with just controlling one strip of 37 LEDs, and all of them do show the same running light. For assembling the TIE Fighter and also for its final destination, I did need some kind of a wall mount, and this is what you will be seeing next. First off, I started with 40 by 40 millimeters tube, which I drilled to 30 millimeters, which is the exact size of the big tube you see going through the middle of the TIE Fighter. And with the help of the bandsaw and an angle grinder, I enlarged that cutout to fit the center tube exactly. I think you're gonna see me test fit it right now. Also, I did weld up some also 40 by 40 tube to create a really basic hinge point. I didn't need any fancy bearings in there. Just a friction fit would be really close enough. When this was all put together, I drilled both pieces to have them line up perfectly. Final assembly went quite smoothly. I just pulled the cables through the polyethylene foam started off with one end cap mounted to the central rod, having one wing lying down on the table. Then I could pull all the other cables through the main body. Put on the other wing, get the cables to the same location, and with putting on the other end cap I could just get everything together, and everything holds by friction basically. Okay, if you made it that far, I guess you're as much of a nerd as I am. But also, that's totally fine. I do leave you with a few shots of the TIE Fighter in the dark, and the very last clip of me tripping over the vacuum cart behind my lathe. So as I said, thank you for watching. Honestly, this means a lot to me. And see you next time.
Ich hoffe, das ist auf Kamera.